Okay, so this is section 12.2, exponential functions. And so let's take a look at the first paragraph of what exponential function in real life relates to. So it says, suppose that an insect population per acre doubles each week. So if we look at the table, we see that here's week 0, there is 100 bucks. Then after week 1, it's doubled, so now we have 200 bucks. And then the second week, and now it doubles again, it's 400, and it keeps going like that. It keeps multiplying by 2. And so when that's the case, the type of equation that we're looking for is that we would have our starting number of 100, and then it doubles, so that's where the 2 is coming from. And now the exponent is the variable that's in this equation. So this is going to cause it not to be a linear equation, but an exponential function. And so you can see that it does work, because when we put 0, 1, and 2 in, we get the 100, the 200, and the 400 like we do in the table. And so that is the crucial piece. So here is the general form for the exponential function. So let's write this all down. So let's go back to my drawing board. Okay, and so exponential function. So exponential functions. Okay, basically it takes on the form of f of x, and that's going to be equal to c times a to the x power. Okay, where a has to always be greater than 0, and a cannot equal 1. Okay, because if that's the case, it will not be exponential. So let's talk about what's in this equation. So c is going to be your initial value. It's what you start with. Okay, a is going to be the growth, or sometimes we call it decay. So it can be decay or growth for a. And then x is our values that are greater than 0, because we typically don't look at the negative ones. So these are all positive values. Okay, so let's talk about growth factor. So growth factor, okay, that would be the a that we're talking about. And growth factors are numbers that are greater than 1. So all numbers that are bigger than 1. Okay, because that will give it a growth factor. Then we have the other one, which is called decay factor. And decay factor is numbers that are between 0 and 1, okay, for the a. So this means they're fractions. So when you have a fraction for a, it's decay. And so that's the thing to know about it. Okay, and so we can have exponential growth equations, or we can have exponential decay equations when we have this. So if you go back to the book and go to the next page, it shows graphs of what they look like. Okay, so here are the two graphs. This is a growth factor or growth exponential, where it starts at an initial and takes off. Okay, or this one here, which is a decay, which starts with a certain amount and then it decays over time in an exponential fashion. So this is the two graphs that you get. Now, what's interesting is how you go about getting these particular values. And so let's just take a look again how we would use them. Okay, so if I were to look at an equation like let's say it's f of x, equal to 10 times 3 to the x power, and we say that we're going to have x be 2. So then it would be f of 2 equal to 10 times 3 to the second, which then becomes 10 times 9. We do the exponent first, and then we multiply. So now we get 90. So f of 2 is 90, or the point is 2 comma 90 is what we get. Let's take a look at another one. Let's say it would be f of x equal to 5 times 1/2 to the x. So this is a decay, and so now we have x equal to 3. So then we put that in. So f of 3 is equal to 5 times 1/2 to the third. So then we do the exponent first. So that's 1/2 times 1/2 times 1/2, which is 1/8. And then we multiply, so that gives us 5/8. So f of 3 is 5/8, or the point would be 3 comma 5/8. Okay, so that's the kind of the idea that we're looking at. Also, just remember the idea of what we have as a being a negative x. That's really the same thing as 1 over a to the x, correct? As we remember our exponents, because we can change this to 1 over a to the x, which then we can go 1 over a to the x, because now we could take this x out. Okay, so that's 1 over a to the x. And so this gives us the idea of how decay and growth exponential equations work.